All right, today we are diving into one of the most fascinating conversations happening, well, anywhere on Earth. We're talking about a conversation between tens of thousands of individuals, one that gives precise directions, and it's a language made entirely of movement. This is the incredible honeybee dance language.
So let's really think about this for a second. Put yourself in the shoes, or I guess the antennae, of a single bee. You're in a hive with, say, 50,000 of your sisters. You've just hit the jackpot, an amazing patch of flowers, but it's miles away. How in the world do you tell everyone else not just that you found food, but the exact precise location?
Well, the answer is somehow both super simple and, at the same time, just mind-bogglingly complex. They do a dance. And no, this isn't just some random wiggle. It's a very specific, highly structured performance that is just jam-packed with information.
And I'm not exaggerating here. This dance is a true language. It uses symbolism, abstract movements that stand in for real-world coordinates. And let's be super clear, outside of our own human languages, this is pretty much the most sophisticated form of communication we found anywhere in nature.
Period. So the big question is, how did we ever crack this code? For centuries, this was a total mystery. It all comes down to one scientist who basically dedicated his entire life to figuring out this secret language of the bees. And that scientist's name was Carl von Frisch. You can think of him as kind of the Sherlock Holmes of the honeybee world. He just knew there had to be a pattern, some kind of logic to what the bees were doing, and he was absolutely determined to figure it out.
And you know what? He pulled it off. He and his team used these special observation hives with glass walls, and for decades, literally decades, they just watched and meticulously documented every single dance. They do things like train a specific, marked bee to a feeder at a known distance, and then race back to the hive to see what dance it performed. And yeah, all that dedication, it earned him a Nobel Prize in 1973.
All right, so what did he actually find? Well, it turns out it's not just one dance. There are actually two main types. Let's start with the first and simplest of the two, the round dance. So the round dance is basically the bee's way of shouting, "Hey everybody, there's some really good stuff to eat right outside." The bee just runs around in these tight little circles, switching direction back and forth.
And the rules for this one are elegantly simple. If the food source is really close, we're talking less than 50 meters or so from the hive, this is the dance they do. It doesn't give any directional info at all, it's just a, "Hey, food close by" alert. To kind of help everyone out, the dancer will often share a little taste of the nectar, so the other bees know what they're supposed to be smelling for when they head out.
Okay, but what happens when the food is farther away? Well, that is where things get really, really cool. This brings us to the famous waggle dance.
This is that famous figure-8 dance you might have heard about, and it's a very specific pattern. First, the bee runs in a straight line, and while it's doing that, it waggles its abdomen like crazy. Then it circles back around to where it started. Then it does the straight waggle run again, and finally, it circles back the other way, completing the figure-8.
Okay, now, the secret to this whole thing, the absolute key that unlocks the entire map, is that straight line part. It's called the waggle run. And pretty much everything the other bees need to know, both distance and direction, is packed right into that one little maneuver.
So first, let's talk about distance. How do they communicate that? It's actually genius in its simplicity. The longer the waggle run lasts, the farther away the food is. A really short, quick waggle means the flowers are just a little ways away. A really long, drawn-out waggle? That could mean they're kilometers away. The timing is a direct code for distance.
And just to give you an idea of how precise this is, get this. A waggle run that lasts for 2.5 seconds, just 2.5 seconds, is telling the other bees to fly a very specific distance, about 2,625 meters. That's over 2.5 kilometers away. How incredible is that? Okay, so that's distance, but the direction part, this is where it gets even more amazing. You have to remember, this entire performance is happening on a vertical honeycomb inside a pitch-black hive. So, how on earth do you draw a map in total darkness?
Well, this is the part that is just, frankly, mind-bending. The bee uses the sun's position outside as its main reference point. But inside the dark hive, it uses gravity. It performs this incredible mental trick where it transposes the angle of the sun into an angle relative to the force of gravity.
So here's how that works. Inside the hive, straight up is their reference for the direction of the sun.
So, the angle that the bee makes its waggle run away from that straight-up vertical line is the exact same angle that the other bees need to fly away from the sun's position in the sky. It's a perfect one-to-one transposition.
Let's run through a couple of quick examples because this is really cool. If the bee waggles straight up the comb, that means fly directly towards the sun. If she waggles straight down, that means fly directly away from the sun. So what if she waggles, say, 60 degrees to the left of vertical? You got it. It means fly 60 degrees to the left of the sun. It is a literal map.
Now you might be thinking this all sounds a little too perfect, almost too incredible to be true. And you wouldn't be alone. For a long time after this discovery, there was a huge debate in the scientific world. Many thought it was just too complex. They wondered, is it really a language, or is there something else going on here?
So you had two camps. On one side, you had von Frisch and his dance language hypothesis. On the other side, you had critics who pushed what they called the odor hypothesis. They basically said, no, the bees are just following the flower smells on the forager's body. The dance is just, a sign of excitement.
So who was right? Well, as it turns out, pretty much everyone was. The modern consensus is that it's actually both. The dance provides the map coordinates, it gets the bees to the right neighborhood. But the scent of the flowers on the dancer's body, that acts as the final street address, helping them pinpoint the exact source of the nectar.
And if you thought that was the end of it, guess again. The story gets even more complex. We've since discovered even more layers to this language. Things like the vibrations in the waggle can describe the terrain, like more vibrations might mean a tougher flight. Different bee species even have their own dialects, like regional accents. And maybe most amazing of all, they are constantly adjusting the angle of their dance to account for the sun moving across the sky throughout the day.
So let's just take a step back and appreciate what we're looking at here. We have a language that communicates distance with time, direction with gravity, and even terrain with vibration. It has dialects. It compensates for the movement of the sun. This is so much more than a simple dance. It's something that should fundamentally change how we think about intelligence in the non-human world.
And that really brings us to the final big idea here. Unlocking the bees' language completely blew the doors off our understanding of animal communication. It just forces you to wonder, if a conversation this complex, this symbolic, is happening inside a simple beehive, what other conversations are happening all around us? What other secret languages are being spoken out there in the forests and in the oceans, just waiting for someone to finally figure out how to listen?